Hey guys, so this is your study guide review. Maybe you'll like this more because if you forget to listen when I'm going over one of the questions, then you can just rewind me. So here we go. I'm just going to fly through the study guide real quick to tell you about the test. You'll have a test tomorrow if you want to call it that. It's an online quiz and I'm allowing you to use your notes. So there's no reason you guys should do poorly. There are 23 questions. Um, Most of them are multiple choice. There are some numerical answers, but you should not get a decimal. I kept it at whole numbers so that you didn't have to worry about rounding and all that. So there are some where you actually have to type in an answer, a number, and then the rest are multiple choice. So with the questions, most of them you've seen before. There are a few new ones, but there are obviously no new skills. So that's what the test is. Don't freak out. Like I said, I could call it a cat or a banana, and it doesn't matter. It's just like doing the same stuff we've been doing. Remember, you can always go back to your previous quizzes. I would have all your notes in front of you to help you, and of course your study guide. So let me run through the study guide. Okay, so number one says, what does a Newton measure? A Newton measures force, and that is equal to force is equal to a kilogram times meters per second squared. Or I'm sorry, a Newton is equal to kilograms times meters per second squared, because force is how much acceleration and mass are happening. How much force does it take to cause a certain mass to accelerate a certain amount? Number 2 and 3 talk about balanced and unbalanced forces. Know that if forces are balanced, like a book sitting on a desk, forces are balanced. The frictional force is equal, and the gravitational force and everything is equal. So the book's not moving. So when forces are balanced, you're not getting any type of acceleration. You could lean against the wall in your house and the forces are balanced. You're pushing on the wall with a certain force, the wall is pushing back on you. You're not moving, you're not flying through the wall. Okay. Unbalanced forces do cause a net change in motion, so they are going to cause acceleration. 4 types of friction. Remember, you've got static, sliding, rolling, and fluid. Fluid can be through air or through a liquid. Projectile motion and the 2 forces that act on projectile motion. That's like if we threw a ball. You guys really entertain me with the flip grids, so I'll try to do some more of those in the next unit. I hope you guys liked them. I thought it was fun and easy and something different. So projectile motion, it's that forward push and then that downward pull of gravity. I know that the quiz before wasn't perfect. I fixed it. Number 6 says, if you are riding in a car and the driver slams on the brakes, why does your body fly forward? Well, that is Newton's second law. It's inertia. An object at rest stays at rest, an object in motion stays in motion unless acted upon by another force, which is why we wear seatbelts. The formula, I'm sorry, that was Newton's first law of motion. The formula for Newton's second law, that is force equals mass times acceleration. And I wrote out everything for you just to remind you. It's probably backwards. So force equals mass times acceleration. Remember, in your triangle, force is on the top. Force is measured in newtons, and newtons are equal to kilograms times meters per second squared. Mass is measured in kilograms. You'll need to know that. And then acceleration is measured in meters over second squared. Don't let that little second mess you up. All right, so that is force. So that was number 8. Number 9, what are action-reaction forces? So that's Newton's third law. For every action, there's an equal and opposite reaction. So if you were stepping off a curb, your foot is pushing on the curb is pushing off of you. If you are hitting a tennis ball, the racket is hitting the ball is hitting the racket. If you were hitting a golf club or swinging a baseball bat or pressing on something, all of those are action reaction forces. There's always, if there's one force, that's an action force, there's always going to be an opposite reaction force. So pretty much anything is an action reaction force that you can think of. formula for momentum. Remember, momentum is represented with a P. I'm on number 10, by the way. P equals mv, so P equals mass times velocity. Remember, momentum does not have that fancy unit. Momentum is just kilograms times meters per second. And then remember, mass is measured in kilograms, and velocity is meters per second. Note that this seems similar to this triangle over here, and it kind of is, but this is not acceleration. So this is not meters per second squared. It's just meters per second because it's velocity. So momentum P equals mv. But you can have these in front of you when you take the test. So there you go. Let's see, what else do we have? Number 11 says, what two things cause the gravitational force between two objects to increase? That is Newton's universal law of gravitation. So remember the distance between two objects and their masses. Like I said, you should have learned this in 7th grade with Mr. Dunkel. The larger the planet, the more gravitational pull that planet has. And then the closer you are to that planet, the more gravity is acting on it. So just know that law. That's just a physics law of nature that you just need to know. The next one, number 12, how do you solve for weight? That is my little formula down here. It's super simple. I didn't give you like specific practice problems on it because weight equals mass times gravity. So really you're just multiplying, and gravity is always 9.8 meters per second squared. It's that universal constant that I told you that you'll always need to know. So it's just whatever the mass is in kilograms. Remember, mass is measured in kilograms times 9.8 meters per second squared. And then weight is going to be kilograms times meters per second squared, which, remember, is equal to a Newton. So weight, the metric unit of weight, is actually newtons, or kilograms times meters per second squared. Either one is acceptable. When you see these numbers, though, if you see like a weird, funky weight, remember it's kilograms, it's not pounds. We're used to pounds. So just FYI. Number 13, what two forces are acting on a falling object? The force of gravity, pulling it down, and then air resistance. So those are the two forces. Number 14, what is inertia? That's just the tendency of an object to continue doing what it's already doing, either resting or moving. And to stop that inertia, you're going to have a seatbelt, or you're going to catch a ball. All of those things are examples of how inertia would be stopped. Friction, of course, too, stops things that are rolling or moving eventually. Number 15 says, what does Newton's third law describe? That's for every action, there's an equal and opposite reaction. A rocket is a great example of this. So everything that pushes out of that rocket, that exhaust, that flame, all of that gas that comes out of a rocket, that's pushing on the ground, and then the ground is pushing back on the rocket. That's how they're able to lift off something that has that huge payload, which is kind of cool. I'm praying we can go back and do rockets the last couple weeks of school. That would be fun to go back and just do a fun project, especially after all this. All right, the next one, number 16. What is the force that keeps an object moving in a circle? This was just a quick definition that I threw out there. That is centripetal motion. Centripetal motion. So if you think of anything that's spinning, like the gravitron or the teacups, that force that pushes you out, that acts on you, is centripetal motion. Number 17. If a moving ping pong ball and a moving baseball both have the same momentum, which one has a greater speed? Well, think about it. A ping pong ball and a baseball. A ping pong ball is really light, and a baseball has much more mass. Okay, so if they both have the same momentum, then the ping pong ball has to be going fast to have the same momentum as that baseball, that same force behind it. So the ping pong ball in this case. Number 18, how does the law of conservation of momentum apply to the train cars? I included this in your notes. This isn't specifically a question, I included this with your study guide. This was also in your notes, but I just wanted to have it in a different location. Remember conservation of momentum. So the momentum, if it's a closed system, so we're assuming there's no friction, the momentum that you start with is the momentum that you finish with, okay? So if I have one train car, say you've got two train cars moving at the same speed, and one train car, I probably should have borrowed some of my son's Hot Wheels or something, one hits the other, that first car is going to slow down and transfer some of that energy to the other car. And now overall, their momentums are still, if we added them together, train car 1 and train car 2, their momentums are still going to be the same. But remember, momentum is P equals mv. So even if they have mass, if they have no velocity, the momentum is 0 because they're not moving. So keep that in mind. So just look over these scenarios. It tells you what they're doing in each picture. Ask me if you have questions. I think the question that I ask you on your little assessment will be pretty straightforward. All right, and then the last one is, how can you double the acceleration of an object if you cannot alter the object's mass? Well, remember, force equals mass times acceleration. So you double the force. And that's it. I really don't even think I asked you a question on that last one. But that's it. Have your calculator, have your notes with you or the study guide with you. Make sure you definitely have the formulas. Maybe look back over your other stuff. Like I said, it should be easy. Online learning, I'm trying to give grace because I know this is hard for everyone, and it's just so different than what we're used to. But of course, if you have questions, let me know. You'll have an hour and a half to take it, but it's 23 questions, most multiple choice. So it's open note, not open friend. All right, that's all I've got for you guys. Thank you for watching. Always, always, always message me if you have questions. Pop into my office hours, or if I need to set up like additional office hours to talk to you or talk you through some of these problems, just message me. I'm flexible. You may hear kids screaming in the background, but I'm here. All right. Love you guys.